No, I don't like that at all.
Take a moment to look over this recipe for a strawberry chocolate cake. Notice anything weird? Probably not. However, it was written by a computer, and even crazier, such a recipe was never part of its training data. More powerful than a queryable relational database, it possesses the capability to write coherent recipes based on any list of ingredients and/or name. There's only one way to test these recipes though, and that's to make them. We're going to make a 3-course meal written entirely by our interim executive chef, Karen. Karen is the culmination of nearly a decade of my obsession with natural language processing and culinary arts. Karen started 5 years ago as a simple Markov chain generator. Over the years, it has been restructured, rewritten, and recreated in multiple forms, from a complex relational database to a generative adversarial network to the version featured here. A transformer-based model trained for 3 weeks on a custom-built, 32-thread, dual GPU, 1200-watt, paper money burning space heater, nicknamed Karen. Why train for so long? Taking vector-raised ingredients as input, our model has just short of 1 billion parameters, all of which need to be slowly adjusted and fine-tuned until a different model, trained to distinguish training data from generated results, is unable to distinguish between real and generated recipes. Training data was compiled from a web crawler written in Node.js that searched for and extracted recipes from a variety of publicly available websites. An archive of English Wikipedia articles was also used first to pre-train the model. This initially resulted in a lot of training data, way too much in fact, and the vast majority was ultimately discarded. I'll explain a little bit more about how the model works later on, but for now, let's look at the effect that training has. After one whole day of training, it generates nonsense worse than the Markov chain-based model I started with years ago. However, after a whole week of training, its output begins to take the shape and structure of a recipe, but it's still full of random nonsense and errors. At 2 weeks, it begins to spit out objectively correct output, but still occasionally throws in a random phrase here and there. 1 cup light Tide NXT liquid caffeine. What the f? I think it meant coffee. It also hasn't figured out that units and parentheses are normally conversions. Luckily, at 3 weeks, the model begins to consistently produce coherent recipes. This recipe for grilled cheese, only cut off by the 100 token limit I use for testing, shows marked improvement in our model. With our model trained, let's get cooking. In the spirit of Food Network's hit TV show Chopped, we'll do 3 rounds with 3 randomly chosen ingredients each. First up is the appetizer round. With the random ingredients bok choy, shrimp, and cherry cola, Karen has whipped together the following intriguing recipe. Thai-style grilled shrimp with cherry bok choy compote. With our recipe generated, let's get started. The recipe starts by creating a quick, sweet, and garlicky marinade for our shrimp. The sugar from the marinade caramelized quite nicely and thickened into an appealing glaze. The 2 to 3 minute time range suggested turned out to be a quite accurate estimation for cooking the shrimp thoroughly. Next, we sauteed and cooked down our greens. The recipe considered this a compote. While not technically wrong, this is probably not the word I'd use. Anyways, the combination of vinegar and the marinade creates a sweet and sour flavor commonly associated with Asian cuisine. The use of cardamom is interesting. I wouldn't have considered using cardamom in a Southeast Asian dish, but it seems like it might add a bit of Middle Eastern flair to this dish's otherwise traditional use of Asian flavors.
Lots of shrimp and a little bok choy, you said?
So now to answer the question, how does it taste? Honestly, and I'm not joking, fantastic. The shrimp was covered in a very light, caramely, slightly fruity glaze that works well. However, both my girlfriend and I agreed a bit of salt could probably have made this a bit better. The greens were excellent as well. The acidity and sugar cut through the bitterness wonderfully, and the butter and spices add a pleasant, warm, savory note. We both cleaned our plates. On to round 2. Our randomly selected ingredients for this round are pork tenderloin, sour gummy bears, and star fruit. The gummy bears are going to be the real kicker, but pork does tend to pair well with lighter, fruitier flavors. Let's see what Karen has cooked up. Pork tenderloin with sour gummy bears and star fruit. Despite the plain title, the ingredient choices are pretty interesting, seemingly Middle Eastern or Hispanic inspired.
I promise this is.
The use of searing and then broiling is an excellent preparation method in the context of lean meats, as it allows for a nice, flavorful crust to be formed without drying out the tenderloin. The use of sauteing the onions until tender and then adding white wine is, while not explicitly stated, a common process known as deglazing. This often builds a host of complex flavors, and it's interesting to see it used here in an appropriate context. We then add our seasonings, followed by butter and lemon juice. Lastly, we add sour gummy bears and star fruit. I just want to point out that this is likely the best order in which these ingredients should have been added. Okay, so first impressions, it's good. If you didn't know what it was, you probably wouldn't even bat an eye. However, it tastes nothing like its composite parts. The fruity flavors of the gummy bears mixed with the savoriness of the wine and onions combine to create the flavor of cheese. It tastes and smells exactly like Parmesan cheese has been melted into the sauce. So it's perfectly edible, even good, other than the unexpectedly weird flavor profile. Additionally, the time and temperature given for cooking the tenderloin was perfect. Last, and certainly not least, dessert. Our first ingredient is circus peanuts. Easy enough. Sesame seeds. Alright. Cherry tomatoes. Here we go. So let's see what we got. Salted circus peanut crostade. Well, first, I wouldn't exactly call this a crostade, but also not exactly sure what I'd call it. A pie or tart, perhaps? To be fair, I'm not exactly sure if I could come up with anything better. The recipe is a bit on the savory side, but savory tarts are a thing, and overall it seems like it might just work. Fun fact, in case you're wondering, circus peanuts are banana flavored. The circus peanuts were pretty hard to dice. I would have used a food processor to mix the crust ingredients together, but the recipe specifically stated finely diced, so we're gonna go with it. Out of the onion, it looks great until you remember that it's dessert. I left it in the fridge for the recommended amount of time, but it never really seemed to set up. Perhaps if left overnight, but either way, let's see how it tastes.
That looks like pizza. I don't know if this is okay. I'm sorry, their fruit juice is...
Okay, so the texture isn't great, and the crust hasn't held up to the moisture from the tomatoes. But the taste isn't immediately repulsive. It's not great either, but it's still edible if you keep an open mind.
No, I don't like that at all. I don't like the textures, because there's too many textures in it, in my opinion.
Overall, this recipe isn't winning awards anytime soon, but considering the difficulty of the prompt, I'd consider it a success. So in conclusion, what have we learned about our model? Well, considering our model doesn't know the qualia or subjective experience of taste, it still has learned to use and apply techniques and pairings in the appropriate contexts. The model is not only capable of learning and applying knowledge directly, but can draw inferences and use knowledge in novel situations. The model also appears not to be afflicted by the errors of overtraining, where the model becomes so proficient at giving perfect answers it lacks creativity and frequently gives rigid, boring answers. This is the primary benefit of a transformer. With a stronger understanding of the relationship between words and a complex model of the underlying language, which they are a member of, our model is capable of modifying and adapting learned patterns to new areas. This is a marked improvement over an earlier iteration that relied on GAN, or Generative Adversarial Network, which worked by training two models. The first model, called the generator, in this case an RNN or recurrent neural network, starts generating output based on an input sentence broken up into small chunks called tokens. Next, a second neural network called the discriminator is trained to distinguish between text generated by the generator and the training data. The two networks compete until the discriminator is unable to tell the difference between the generator and the training data. This model often produces results that look great at first, but lack coherency, and it's extremely prone to overtraining. The generator can only become so good as to generate text that looks real to a computer, but not necessarily to a human. The pre-training Dunn on a transformer-based model aids in building a more conceptual understanding of the usage and properties of words. For example, given the task of completing the statement, "We were served steak, fries, and green beans. I hate most vegetables, so I ate everything but the blank." Simpler models, such as Markov chains, may suggest any number of different words that commonly follow the words "but the." Even the most complex models, like the aforementioned GANs, may more correctly suggest words that fit the general theme of the sentence, eating food, but will lack a conceptual understanding of the sentence, suggesting completion such as steak, wine, food, etc. Words that don't stick out as being wrong at a glance and are grammatically correct, but lack an understanding of what is being stated. This is all in contrast to a transformer's understanding of the way a language works, and its ability to map the relationship between the words in a sentence, such as the understanding that steak, green beans, and fries are being served, that the speaker doesn't like vegetables, potatoes and green beans are both vegetables, that one of the food items is being excluded, and given the fact that green beans are more commonly associated with disgust, green beans are the best fit for completing the sentence. Karen is by no means perfect. The best example of this is a recipe it gave me for pork ceviche, which, while it looked great otherwise, featured raw, diced pork tenderloin, a potentially dangerous combination. The model lacks the understanding that raw pork, in almost any context, isn't safe. The training data, written by humans, is also wrought with human error. Without human intervention, the model can't discard misinformation. At some point following the launch of this video, I'll have a publicly available version of Karen in the description. Creating a publicly available interface poses a few problems concerning safety and security, as well as economically, but I have plans to deal with them. Until next time.